Hello to our early joiners of the webinar. We'll just give it another minute or so, just as a few more people come in. But yeah, we will get started straight away because we only have 30 minutes and there's quite a bit to go through. I'll just give it a little bit longer, but I suppose for the people that are here at the moment, you can ask questions directly through YouTube if you wanted to do that during the meeting. And if you want to do it through the H2X page, I will get an email. Might not see it till the end of the webinar, but I will answer it then. But yeah, okay, well, let's get started then. Thanks for joining and welcome to the webinar, which we're going to be talking about designing a heating system within H2X. My name's Jonathan Mosdell. I have a mechanical engineering background and I'm one of the co-founders here. And during the next 30 minutes, we're going to be showing you how to use H2X effectively. And we're going to be going through all of the settings that inform calculations, how to draw your system, and then we'll review all the results and we'll take a look at the exports. So that includes things like PDFs, bill of materials, and some design reports too. And the aim is by the end of the 30 minutes, you've got all the information that you need to then log into H2X for yourself, design a system, and you should get all the benefits that H2X offers. And just to reiterate what I said earlier, please feel free to ask questions. I'll answer the heating ones as I go, assuming that I see them. And for any that come to my email or that aren't specifically related to this exact webinar, I will answer them at the end. But yeah, I will get started. So we will be doing a new build today. So going from an off-plan design and just designing a new heat pump system. But I just wanted to show you another use case before we got into that, which is a client of ours or a user of the software has used this to go and do a survey of an existing building, which is what you see on the left here. So they've got the building layout, it's got a gas boiler, they've chosen the pipe sizes, they put in the specific radiators, and if you can just see, the text in the rooms are all green. So that means there is enough heat being supplied to the room. And this will all make a bit more sense as we do the design. So don't worry about, I suppose, understanding why certain things have happened, because we will cover that. But just to talk about the use case, the building works with a gas system. They've then gone and swapped out this for a heat pump, and obviously there's lower temperatures, and because of that, the room text is no longer green. It's more of an orange, and the reason is because at the lower temperatures there's not enough heat output to the system. And then if we go across all the way to the right, this is where the user has replaced some of the radiators. So as you can see again, the text has now gone green, and where the pipes are yellow at the bottom here, they've been able to override the pipe size to keep it what is currently installed at 15. But if you can see at the bottom of this box here where it says velocity, it is at 1.14 meters per second, so a little bit higher than what's recommended. But overall here, I just want to show that for people that want to use the software, it provides much more detailed information. First of all, for yourself to do the calculations and know what you're doing is going to work and be correct, but also for trying to win jobs and showing it to the client. You can show them that you've really done the details and give them the confidence that what you're going to do will work because you've put the time and effort in, and you can give them a lot of documentation to support that. So that's just one use case, but now we'll jump straight back to the beginning and we're going to be going through a heating design from the beginning. In this, I've already done the heat loss calculations. So that was covered in a webinar yesterday, which you can still find on our website if you missed it. Or at the end of this webinar, I'll give you some links to where you can go and learn about it. But essentially, we've got to the point now where we've done the heat loss on this building, and we can see that with the the red text, which specifies the kilowatts in all the rooms that are required. All right, so before we start doing the design, I'll just point out some of the settings. So up here, there are a lot of different settings and they're not all related to heating. So if you don't understand them, don't worry about going through them all. The most important ones is under calculations is the pipe sizing method. So do you want to size on a maximum velocity, a maximum pressure drop? Most commonly people do both. And then under flow systems, you want to go to heating. And there's a lot of information here, but just to call out the most important ones, the temperature is important. Feel free to change colors and names if you want to. But really, it's the pipe sizing parameters for risers, which are your vertical pipes between levels, which we're not going to have today, so we'll leave that out. And reticulation, that's essentially just your horizontal distribution pipes. So it's set to a maximum velocity of 1 meter per second, a maximum pressure drop of 350 pascals per meter. So it will never exceed those two. You can change these numbers as much as you want. Got a whole range of materials here too. So if you didn't want to do copper, go with anything else. And you can choose a minimum pipe size. So if you want to go down to 10 millimeters, you can. If you don't want to go below 12 or 15, you can choose that too. But in terms of the calculations, they're the only ones that matter. So if you're following along, I would just go through those. All right, and then you want to make sure you're in the design tab here. And once you're in that, you can start doing the design of the building. There is a preferred way of drawing your system out in H2X. So I would recommend following what I do in this webinar, because things snap together in a certain way. So people sometimes like to put in the radiators first, for example. And although you can do that, and that's fine, it just means connecting them to pipes gets a little more tricky. So it is better to do equipment first, then your pipes, and then your heat emitters. Not essential, but yeah, if I was ever designing, that's the way I would do it. And that's the way I'll go through it today. So, all right, let's put a heat pump in. And I should just say, I'm not going to focus on doing the most perfect design. This is more for training you how to do it. So for example, let's start by putting the heat pump in, and I'll just place it over here without much thought if it's the best location. So you just essentially click, stamp where you want it. So do a left click here. And then when you click on it, it has its properties which appear on the right hand side. So this is pretty typical for most things that we'll look at today. You can always click on it and look at the properties. Most of it takes industry defaults and probably don't need to be changed, but some of them are project specific, so you will want to just at least check them. And I'll go through them today. So on the specification side, you can change the shape and the size. So if you want it a little bit bigger, you can change the depth, and it changes slightly. For the SCOP, so this will go to the energy report we see at the end. If you did want to change that, let's go with 4.5. You can just put that number in. On the inlets, there are no inlets to the heat pump, so we'll skip this one. For the outlets though, most important thing here is the temperature. So let's say we want to go with 45 as the outlet temperature, and we want a 5 degree delta T, so we want that to return at 40. Then if there's pressure drop through the heat pump that you want to add on to your index length and recirculation pump duty, we can type that in here. Let's just go with 0.1. And the last one is noise. So this will do the MCS noise report for you based on a few inputs. So I'm not going to spend too much time thinking about this. I'm just going to pick some just so we can look at the result later. But just four entries there, and yeah, it'll do all your noise reports for you. Okay, next I will put in our domestic hot water cylinder. So back to the equipment drop down, choose the cylinder, and just like we did with the heat pump, I will click where we want it and then click on it to bring up the properties. The specifications are similar, so we've got things that relate to the shape and the size, and then we have things that relate to the energy usage. So how many liters of water a day? Let's just go over 100, and yeah, the SPF will leave at 4. but it's going to use this later to look how many kilowatt hours it uses per year. This time the inlets are important because we're connecting to the inlet of the cylinder. So we can connect cold water if we want to, but we won't do it today, so I'll just leave that. We could change it to no if we wanted to. There's no gas. But there is a preheat, which is essentially the heating inlet. So there's a few things like the height you can choose here, but to work through the technical properties, for the rating, this is how many kilowatts you want to take from your heat pump. Most people match this to the heating demand of the system, which I think was around 4.5. So we'll put a diverter valve in shortly, but it's essentially, or the software is going to take either the largest of the heating demand, space heating, or the hot water. So most people size the heat pump based on the space heating demand and then use the exact same kilowatt to go to the cylinder. But of course, put any number you want in there. The volume, this is for the system volume calculation, not the volume of the cylinder. So whatever litres we put here will be added onto that. Pressure drop through that coil as well, you can change it. And then for the Legionella purge, which will inform the energy calculations, choose the temperature and choose the frequency. Whether it's every day, every week, or every month. The more frequent, the more energy it's going to use. And then this time it's the outlets that don't matter. So in H2X you can design a domestic hot water system, but we're not going to be covering that today. And a lot of people don't do that if they're doing a heating design. But if you wanted to, there is YouTube videos I'll reference shortly, which will help. But yeah, if you're adding any of the other equipment now, like headers, buffer tanks, volumizers, it's all the same process. So just work your way through the tabs and input the information. All right, the next part now is I always draw the pipe layout. So this is the riser if you want to go up a level and connect your pipes between levels, but we don't have an upstairs today, so I'm just going to leave that. You can draw your pipes one at a time, so you want to draw your return pipe and then your feed pipe, you can do that. But it is much faster to do multi-pipes. So I'm going to use this one, and this is useful for projects like heating because you can hover over whatever's in the circle, like there'd be 3 here, which we wouldn't want. But for example, there's 2 in this one now. And if we start clicking, it's going to let us draw these pipes at the same time, which is really useful. And you can try to line these up. So if we do something like this, sometimes it's easier to, if you can't get it to connect perfectly, just stop a bit short because then dragging things becomes really easy. And once it goes a solid color with the arrows, you know it's all connected. Things do come standard with a lock shield valve, which are required on every circuit to balance the system. So make sure you've always got one of them. And they come with control valves quite often. If you don't want it, press delete. It's just as easy as that. And if you have deleted, say, a lock shield valve by accident, or you just want to put another valve on, we have this valve drop down menu here where you can choose them. But I'll do a diverter valve in this example. So choose the one that you want. It is then grey, but as soon as it intersects with a pipe, it turns coloured. So we want to put it on this point here, and then press done in the top left or escape on your keyboard, and it goes away. And then we'll do the rest of the pipe layout. So multi-pipes again, hover over these 2 points. I'll just run some pipes through the middle for now. Press and escape again once I'm done. Okay, so the last part to this now is just adding the heat emitters. So there's a few different ways to do this. You can specify existing radiators, you can size new radiators, you can put manifolds in. We'll touch on quite a few of them today, so you've got a good understanding of the different ones. I'll start with the simplest one, which is just specifying a kilowatt rating into a room, which helps to size your pipes. So for this utility here, if we click on radiators, we've got 2 options at the top. So I'm going to go on fixed rating, which just means we're just going to pick one that's the closest. You can add your own as well. So you can create your own like Stelrad range or any other manufacturer range and choose from them. So for this first one though, we'll just go with the generic 0.25 kilowatt. And as you can see, as I move around, this radiator will snap towards the wall. So to help the placement, so we want it against this wall in the utility. Click once, and then you'll see the pipes are now drawing, follow my cursor. So we're going to click again where we want to connect, which is here. Once I click, I can then click escape, and that's done. So that is the main reason why you want to follow this in a certain order of equipment, main pipes, and then heat emitters, because it makes this much easier. If I hadn't drawn these main pipes, I could still just click here. It just means I've got to go connect them up later. So it's a bit easier to do it this way. All right, so a couple of other options with adding radiators. Let's do the study room next. So let's say we want to put a radiator below this window. We don't care how wide it is, but we don't want it to go, say the window's a meter above the ground, so we want it to be below that. So I'll click on radiators. This time, instead of fixed rating, we're going to go specify which type of radiator. We'll keep it on 11. And because the window's at 1 meter, let's say we want to limit the height to 0.7 or even 0.6. Now, when we put this radiator in, you'll see that, well, the width is being provided automatically. So if we put it in here, you see the width gets smaller, gets a bit bigger here, gets even bigger here, and gets a lot bigger here. All because it's looking at how many kilowatts it needs to provide. It's looking at the limitation, and then it's calculating. And sorry, I should just mention that the text in the rooms are turning green as we add these. Like over here. And sorry, I forgot to mention on this one, we've put a 0.25 in, it only needed 0.23. So if you did want to, you can click on this. You've got the properties here again, and we could just change that to 0.23. So pretty easy. Now let's use the same example as what we just did there, but this time we want to fit the radiator in a narrow space, so we can go limit by width. So let's go still at 11, limit by width this time, 0.3, which looks like this. And yeah, it's worked out the height for us, which we can't specifically see, saying this like towel rail or whatever it may be, but if we click on it, we can see that it needs a height of 630 mil to be able to provide the right heat output. Okay, and then the last example of the radiator. This is more for an existing building, so you can specify and you can do it exact. So you can say it's a type 21 and it is, you can pick it from the table, or you can say it is, I'll make it small so we get a bit of an error. So 0.5 meters high by 0.4 meters wide, make it type 11 then. And follow the same process, connect and snap. But as you can see now, that is only providing 0.17 kilowatts, and we need 0.27. So this was going back to the example at the beginning of retrofitting. It will tell you if what you have isn't suitable. And it's really easy to make changes, like we can change the size, or if we want to make it a 22, that's gone from 0.17 to 0.22, and then if we make it a 3.3, it's gone from 0.22 to 0.32. So you can play around with it and get it to work. All right, and then the last thing I'll show you now is HTRX doesn't do the underfloor heating layouts. It will do in the future, something we're going to start working on soon, but right now it doesn't. But it goes up to the manifold. So most of our users use these. So again, we have a lot of default ones to choose from. But I'll just show you creating a custom one just so you know how to do it. So between the kitchen and the lounge that might have underfloor heating, let's say it's 2.9 kilowatts. So I could use one of the existing ones and just change it, but let's add a new node here. New heating element. So you can choose what type of heating element you want. We'll go with the manifold. And then these next three about the shape and the size. So let's just say we want it 700 wide, maybe it's 300 deep and 400 mil high. The rating is the important one for the calculations. That's 2.9 kilowatts. The volume goes to the system volume calculations. So how many liters per kilowatt do you want to add to your calculation? 11's the placeholder. So that would be 11 times 2.9, nearly 33. So feel free to change that if you want. What pressure drop do you want through the manifold that will go onto the recirculation pump and the heat pump? And then what height above the floor? So maybe we'll go 1500. But yeah, click create once you're happy with all that. Back to your project. Drop this down, and now we can see this 2.9 kilowatt manifold. And that is snapping to the nearest pipe, so I can place that wherever. Maybe over here I want to put it in the corner. So I can, place that down, and that is now connected. So this room is obviously green, and it's got 2.9 out of 1.7. It's not recognizing this as enough, but we know that this caters for it. And we don't need these pipes anymore, so we can click on it and press delete, or just press delete on the keyboard. And that is everything you need to do to design your system. So I think that might have taken about 12 minutes to do this. Relatively simple layout, but that's while talking. I think if I was doing this for myself on a project, probably doing like 3 or 4 minutes, which just shows like when you learn how to use the software, it's really fast, and then the benefits compound now. As I click results, it takes those few seconds. Everything has been verified by CIBSE in terms of pipe sizing, flow rates, velocities, and a range of other things. And on the right hand side here, there's a whole load of information we can turn on and off, which I won't do right now because there's a lot to go through. But for example, you can see the index circuit is being shown here, so you can turn things like that on or off. But just to go through some of the main ones, if we come into the heat pump here, we can see if we hover over it, we've got the total system volume. So it's telling us we've got 76.5 litres in the system. The total heat load is 4.9 kilowatts. So like a 5 kilowatt heat pump required. And the index circuit length is nearly 28 meters. We've also got the recirculation pump details here. And you can choose whether you want to see it in liters per minute, liters per second, or something else. And then we've got all the pipe size in here too. So 22 mil pipes. And if we hover over it, we can see how much pressure drop per meter. It is just below the 350 threshold. So if there's a little bit more here, it would push us up to a 28. And the velocity is 0.75. And you can go around the system and look at that. You can see we only have 10 mils go into to these radiators, which you might expect at very low flow rates. But yeah, you can go around the system and review a lot. I won't go through it now, but the main thing is pipes are all sized and equipment's all sized too. We can now use this information to move on to some exports. So there's quite a few things here. I will show you the top 3. So let me start with the bill of materials first. So the bill of materials takes everything you've drawn and it puts it into a bill of materials. So you get a list of everything. Sorry, it's just opened up on my other screen. Let's pull it across. So if we start coming down here to the heating supply, it will be on a level by level basis. Pipe material, different sizes, different lengths, and they're just a placeholder at the moment we have for the cost, but you can put in your own cost to get totals. But to show the level of detail, goes to side, center on the T's, got the quantities, number of elbows we have here, all the different valves, and a heat emitter schedule too, as well as the equipment. So a very detailed breakdown of everything that you have drawn and has been sized. So you can use this information or take it into your own estimating software, or if you want to, you can bring your own rates in to here as well, and it's all linked. So just really helps with quoting jobs and looking at different design changes and what the cost implications are. For the heat loss report, so it contains a lot of information on the heat loss, which we went through yesterday, and I know we've not focused on today. Let's bring it across again. So I won't go through the heat loss part, but just to reiterate some main points, it's branded, it has a summary of all the information, has a breakdown of all the heat loss that has taken place, all the technical details. But then relating to what we did today, we get the heat emitter summary. So this is telling us for all the rooms what heat emitters are in there, what is the load specified, and have we met the demand. And we have in most of them, other than the room that is coming off the kitchen manifold. We've got the noise calculation form here, so following MCS, it does tell us that yes, the result is lower than 42, so that's great, and it's got all the workings here. And for the annual space heating demand, we entered the degree days in the settings for the heat load settings, and then it's telling us that's how many kilowatt hours per year, and that is where the power is coming from based on the scope that we set. And then same for the annual domestic hot water demand. We're using this many litres, and we get a breakdown of that's what we're using throughout the year, and then where is it all coming from. So the heat pump and what's being supplied for domestic hot water and what's being supplied for the Legionella as well. All right, and then the last one we'll show you is the PDF. So when you're quoting your jobs now and you have all your detailed information to go with it, you're also able to export a nice PDF visual of the system that comes branded with your logo and looks professional with a title block and things. So first of all, you can choose a paper size. I normally go large because you can fit more on. So you want to try and go the biggest page possible and fit the building on as nice as you can. You can choose the detail level. There's definitely a sweet spot. So you can just scroll that and you get a good visual on the screen. I usually turn the cover sheet off, but you can have that. And what's important is any results, blue ticks that you see on the right hand side here, they will show on the export. So if we didn't want anything other than the total heat load to show, turn those off. If we didn't want to show that index circuit highlighted, turn that off. Choose if you want the title block horizontal or vertical, and then yeah, just do a quick export. This will now come out on a PDF, so fit it to the screen. It will have your company logo, has all your project information like the client, who's been designing it and things like that, and you get a nice visual of what you've designed. So what are all the pipe sizes, what are the where's the index circuit, and just whatever else you want to show. So it just really elevates the quality of the documents that you provide. And as we're coming to the end, that is everything I wanted to run through today. So did cover quite a lot, a couple of different use cases, whether it's a new building or whether you're retrofitting a heat pump. And then obviously took you through the steps of adding your equipment, drawing the pipes, and then adding the heat emitters too. You get all that range of all those range of exports with the accurate results. And I suppose just as some next steps of this last minute, I would just say we have a YouTube channel here. If you search for us, come to playlist. For those of you that missed yesterday, we've got a full heat loss one here. And then for the heating design, for example, you can say view full playlist. And just a minute, 2 minutes long on drawing pipes, adding heat pumps and things like that, which will just be similar to what I went through today. But yeah, you can follow it at your own pace. This webinar will also be able to be replayed. And then last thing I just want to say is you get a 2-week free trial. So if anyone wants to come to our website, h2xengineering.com, you can try it for free. And you can also book a demo as well. So if you want to speak to myself or one of my colleagues, we can do a one-on-one session with you or your company, go for any use cases that you have, and yeah, just help you get started. But other than that, thank you for your time today. I appreciate you coming, and yeah, I'll just look at any questions we have, but yeah, feel free to send more through as well. We do have one from Graham asking about the radiators we specify. Are they saved? So yes, you can create they don't come standard because we don't want to align ourselves with any particular brand, but you can create your own range in a template project. So you can put all your Stelrad ones in, and then when you start your next project, you just duplicate your template project, and from there, yeah, you'll have all of the radiators that you've specified. And that template project goes for other things as well. Like if you want to go through and put all your rates in, you want to set your velocities up, all your materials, add your Stelrad radiators. You can do all that in a template project, and then yeah, every time you start a new project, you've got it all there for you. Alright, we do have a question from Valentine. Ken, have you got a pre-plumbed cylinder with the valves integrated? I wouldn't say pre-plumbed now, so you'd have to do it separately. So you can put a cylinder in and then put your valves in separately. But saying that, actually, I suppose what we do have is we do have the cylinder that comes with storage. So essentially, let's say we do that, you have your cylinder, but you just connect to it and then you connect to the outlet. So it essentially does come pre-plumbed with the diverter valve in that case. Yeah, that's all the questions for now. I'm happy to just wait on another minute or so to see if any more come through, but if no others do, just again, thanks for your time. I hope you all found that useful. All right, well, yeah, I will end it here, but my email is jonathan@h2xengineering.com. So if there's any questions that want to come through directly, please feel free to email me, or again, you can get in touch with the team through the website. But thank you, and